coming to the nature of the roots which I've discussed, right? So a quadratic equation at max will have two roots or two real roots. That is what we are worried about or have some concern for. So there is something called discriminant. So discriminant is b square minus 4ac. So if that is greater than 0, right, I will have two different real roots. Why would this occur? Let's look at the roots, right? What are the roots? Minus b plus or minus square root of b square minus 4ac by 2a. See, this is discriminant, right? So it is like basically saying minus b plus or minus square root d by 2a. If d is positive, then square root of d is square root of some positive number will give me a real number as output. So I'll get minus b plus or minus some real number by 2a. So I'll have two different roots, minus b plus square root d by 2a, minus b minus square root d by 2a, and both of them is root 1, root 2, and both of them are real roots. And they are two different real roots. That's why I'll get two different real roots. If discriminant is 0, what will I end up with? Minus b plus or minus square root of 0 is 0 by 2a. So the root will be minus b by 2a. I don't have plus 0, minus 0. Both of them will be same, minus b by 2a, minus b by 2a. So what will I end up with? Real roots, yes, two real roots, but they are equal. So it's basically only one unique root, but they look like two. Why would I call them two? If I ask you to write the quadratic equation for, if it has root minus 1, minus 1, it is simply x plus 1 into x plus 1. So that reason I need to count that there are two. Otherwise, if I only count one root, I'll end up with only x plus 1 as the equation. X plus 1 equals to 0. But that is not a quadratic equation, right? For that reason, I should understand both of the roots are existing, minus 1 and minus 1. But it's the same value. That's why they're equal roots. If discriminant is negative, so minus b plus or minus square root d by 2a. If this is negative, I'll end up with square root of minus something. So that will give me imaginary number, right? Minus b plus or minus something into imaginary by 2a. This is all complex stuff. So which is not real roots. That's why I'll end up with two complex roots. So they might ask questions like, if there is a quadratic equation 2x square plus kx plus 6 equals to 0, for what value of k would that give me two different real roots or two real roots which are equal or two complex roots? All you need to do is just make sure b square minus 4ac equals to 0 for two roots which are equal, or greater than 0 for two different real roots, or less than 0 for the complex roots. So b square is k square minus 4 into 2 into 6, right? And then you will get to a k square minus some value, then solve it like a inequality and get the value.